Hi, I'm Rex Black, President of RVCS. Welcome to the RVCS YouTube channel. Hey, I hope you enjoy all these free resources that are available here. And do us one favor. We need to keep the lights on and we need your help to do that. So, when you need testing and quality related services, training, consulting, expert services, you name it, let us be one of the bidders on that next job. We don't expect to get all of your business, but we'd like to get a chance. Thanks and enjoy the shows.
Type of requirement it applies to, you'll see how this works as it goes through the, if you go through the requirements catalog, and then it generates, the technique generates a set of tests, and this is the set of test IDs here. Here are the test cases themselves. And what I've also done in these set of tests that were generated, the 6 sets that were generated, I checked to see if this was something that would have been generated by the other techniques. So it wants us, the requirements catalog wants us to test -1, 0, and 1. And those are values that already would have been forced upon us by McCabe or generated by McCabe's technique. And then it wants us to test the maximum value that can occur, and that's or can be input. Excuse me. That's 2 billion and change on a 32-bit processor. And we would have tested that also with the statement branch condition loop kind of code flow coverage anyway. But there are some things that McCabe says that we should definitely do that we wouldn't necessarily have had to do. For example, he says that you should select a typical value, which I said 10 would be a typical value, so it produces this Fibonacci series that you see here. Typical value in the input range. And then also try a value where the input and is going to be different than the return. Notice that we return n unless the input is less than 1, in which case we always just, or excuse me, less than 0, in which case we always return -1 as a code saying that we got a invalid value. So it's saying you want to check that happens. You want to test that reassignment of the code. So it does tend to generate some tests that you wouldn't otherwise necessarily have looked at, and so thus it is an interesting technique and potentially useful. Okay, so that is sort of a roundup of the common techniques. Here, this slide shows a recap of the test design approach with Merrick's tool. You review the requirements, design, code, and structures, compare the elements of this checklist or catalog, and then you accumulate what Merrick referred to as clues, which were the test requirements to be run, and then you create tests that cover those. And one thing interesting that Merrick said was try to use as much variety in your input data as possible, because you might stumble across a bug that is hiding in there and not amenable to discovery. So that's another good insight from Merrick, that the other code coverage techniques say, well, it doesn't matter what input values you use as long as they force particular code flows or data flows, in the case of data flow coverage. Merrick said, no, it really does matter. You should try to have as much variety in your data as you possibly can. So we've looked at these different techniques, and we say, okay, well, the white box sounds like it could be useful, but how does this compare with other techniques that are out there? Well, basically, you've got static techniques like reviews and static analysis and so forth that involve testing without running, and those are going to identify bugs before, in some cases, before the bugs are built if you're doing a static review of a requirements or design specification. This is something that would typically involve, ideally, as many stakeholders as possible and happen during specification and development. And then there are a wide variety of tools available to do static analysis and support this. So it's a good idea to use static techniques, including code reviews, but also other things, prior to getting into coding. I mean, once you've created the code, then you know, your opportunity to prevent bugs is gone. You're now going to have to just grind the bugs out. So as we've discussed, whitebox testing is testing how the system works, and the idea is to identify functions in the bugs or in the interfaces between, or identify bugs in the functions, excuse me, or the interfaces between functions. This is typically done by programmers as part of, say, a unit component or integration test, and there are also plenty of tools to support this, though, again, I'd be curious if any of you run across a data flow coverage tool. And then we have, of course, the black box tests, which would be, you know, testing what the system does, looking for bugs in the results and the behavior of the system. And this is typically the domain of independent testers, and often predominates at the higher levels of testing, like integration system and acceptance. And as those of you who are testers know, there are plenty of tools to support this. Now, these techniques are complementary and can be can and should be used on every project, or just about every project, because they tend to find different kinds of bugs. They have different strengths. So by using a good mix of different techniques, you're going to tend to find a lot more bugs than if you just bang away with one set. Okay, so as I've said, you know, measuring this stuff by hand, doing these code coverage and psychomatic complexity stuff, not something you're going to want to do for fun, but in some cases there are tools. But as I said, I'm interested in anybody's comments about data flow coverage tools, if anybody's seen one, or if anybody has seen a test catalog coverage tool. I'm not sure that would exist. Fortunately, I think Merrick's technique, like Whitaker's technique, is much more focused on leveraging the skills and experience of the tester. It's not as tedious. It's more of a kind of tips on how to explore the code from a white box perspective. Now, white box testing is good. White box testing is important. I would encourage you all to take it up if it's something that you can apply, or if you can't apply it yourself, to try to make sure that it is being applied by the programmers within the organizations that you're working with. But it's really important to not have a blind faith in white box testing. I think there is sometimes an overconfidence that, so if we test the units really well, then, you know, everything's going to be fine. And I think some of that is kind of embedded in some of the things that you hear people say about agile technologies or techniques these days. You know, of, oh, well, you know, we're going to thoroughly test the units during unit testing, and that reduces the need for subsequent system testing or acceptance testing, or at least it makes it you know, a much lower effort. Now, that's sure, it should be a lower effort, but, you know, I go back in this to Capers-Jones's studies, and he's come up with a figure from his studies across these thousands of organizations and projects that really unit testing is going to top out at about 50% of defect removal effectiveness. So in other words, you're only going to find and remove about half of the bugs. So what can't we find with unit testing? Why would it top out at 50%? Well, part of it is based on the fact that the developers are typically testing their own code, so there's an author bias issue in there. But there are other things that make white box testing not 100% effective against bugs. Of course, nothing is. One thing that you can't find with white box test, or what could be called bugs of omission, so missing requirements, design elements, code, that sort of stuff, you can't find that, because the code's, you're only going to test what's there. You can only check your coverage of what's there. You can't look for what's not there very effectively with white box testing. So requirements, design, and code reviews are the way to try to find those sort of problems. As I said, it's complementary kind of testing. Unmaintainable code. You could have perfect white box test results and have the code be completely unmaintainable. So, variable names that don't mean anything, so forth. McCabe's cyclomatic complexity metric, being a form of static analysis, can help identify unmaintainable code if that has to do with excessive branching. But code reviews and other kinds of static analysis tools are really the way to attack unmaintainable code problems. And then there's a lot of what I refer to as emergent behaviors in systems. So performance issues, security issues, usability, interoperability, and so forth. Those are not really manifested at the unit level where a lot of the white box testing is done. So we need to have code reviews and system testing and beta tests and usability studies and prototypes and all those kinds of things to go after those emergent behaviors. So a few conclusions here before we go into the Q&A session. As I said, white box testing is a form of dynamic testing, and it is based on an understanding of how the code works. We have the four main groups of techniques: the control flow coverage, basis paths with McCabe's technique, data flow coverage, and then the test requirements catalog, which is bug coverage, if you will. Tools are very useful if you can get them, and there are many freeware as well as commercial tools available to support this, so I'd encourage you to look for tool supports if you're going to do this. And then, as I've just pointed out here towards the end, white box testing is complementary to black box testing and static testing. It's not a substitute. You should employ throughout the organization all three of those types of testing to have a complete testing strategy. Okay, so I will, as usual, put the advertisement up while we go through and then enter our Q&A session here. So at this point, I'm happy to take questions from the audience. See a number of you have already figured out how to use the tool to submit questions, so let me get those questions out in front of me. This is a new version of GoToWebinar here that they've introduced. It's made this understanding where the questions are a little bit difficult. And let me give me just a moment, if you would, please, and I'll try to get this question panel up. There we go. Good. Okay. Let's see. I had a question from Shmuel at the beginning. Question: will we receive a copy of the slides? As I mentioned at the outset, the slides are posted on the website, so that's rbcs-us.com on the, I believe it's the basic library page, where you can find those slides, and you can download them. That's just the presentation. Now, the recorded version of this webinar will be posted on the digital library page of our website sometime probably in the next few days. So if you'd like to say, tell someone, hey, I heard this presentation on white box testing metrics, and it really helped clarify a lot of points for me, and suggest that you catch it too, then they can, anybody that you're interested in, you can just forward a link, and they can listen to that at their leisure. And it's basically, it's a WMV that includes all the audio of the presentation and the slides animated as well. Tim, thank you. Tim Riley, my colleague and editor on the book Beautiful Testing that I just contributed to late last year, says the Google search works. Structured testing. This is McCabe's paper. This is on www.mccabe/ looks like iqresearch_nis.html. Let me see if I can let's see. I'm going to try to get this link up and running, but looks like if the Google search works fine, you'll be able to find it easily enough. So McCabe structured testing. Let's see, next question here, one from Shmuel. Doesn't covering all the branches automatically cover all the statements too? Yes, Shmuel, good observation. branch coverage will achieve statement coverage because in order to get to a branch, you would of course have to go through all of the statements, at least through some sequence of statements that preceded the branch. And if there's a non-branching block that precedes the branch itself, as we saw in the Fibonacci program, you'd have to run all of the preceding non-branching statements before you got to the branch. And then once you got to the branch, then there could only be 0 through n number of non-branching statements in each block associated with a branch. In other words, the true and the false side would each have some number of statements there. So the only way that you could get to those statements would be by taking either the true side or the false side of the branch, and that argumentation, if you will, applies pretty much indefinitely as you go through the program. So yes, you will always get 100% statement coverage if you get 100% branch coverage. However, the opposite is not true, and the reason is, this is that point that I stressed earlier, in a switch case construct, there is a default branch even if there is not a defined default block. In other words, there's a possibility of none of the case labels matching the switch variable value, in which case we do nothing. That's the default branch. In an if statement, there's always an else branch, even if there's not a defined else block. So if we say if x greater than 0, decrement x, and then semicolon, and that's it. There's still an else branch there, which is do nothing to x or anything else. So be careful of assuming, well, if I test statement coverage, branch coverage, it's all the same thing. No, statement coverage does not imply branch coverage, but branch coverage does imply statement coverage. Payush asked an interesting question here. How can we map or measure the code to the requirement coverage? These are really two different things, Payush, that are not, they're complementary. So if we're talking about the requirements, and here I'm assuming we're talking about requirements that specify the desired behavior of the system, then that's black box testing, right? That's testing based on requirements. Now, the code coverage is white box. Now, the fact that there's not necessarily a mapping from those two things, from the requirements down to the code, is not necessarily a problem. Now, in some industries, it is a requirement that you do that you have traceability down from the requirements to the code. Certain regulated industries have that as a requirement. But from a tester's point of view, a professional tester's point of view, really what you want to do is say, well, I want to come at the testing problem from multiple angles. So there's a certain kinds of bugs that static techniques like reviews and static analysis are good at finding, so we apply those. And then there are certain kinds of bugs that the different white box techniques are good at finding, so we apply those techniques and find those bugs. And then there's other kinds of bugs that the black box techniques are good at finding, like equivalence partitioning and state-based tests and exploratory testing and so forth. So we can apply those techniques. Basically, the idea is that as you proceed throughout the software development lifecycle, you're applying a set of appropriate bug filters at each stage of the lifecycle, and that's achieving the desired effect of ultimately filtering out most of the bugs. And this is a fairly easy exercise if you just think of, if I have 100 bugs and I do static testing and it finds half of the bugs, and then I do white box testing and it finds half of the bugs, and then I do black box testing and it finds half of the bugs, how many bugs are left at the end? Well, 500, 250, 125, right? Because half of 1,000 is, or excuse me, 100 is 50, 25, and then 13. So you get out 87% of the bugs, even though you're only 50% effective at any one of the phases. And so that sequencing of testing is really what you're trying to accomplish here. And so don't worry too much about, establishing relationships between requirements coverage and code coverage. What's more important is applying the appropriate filters at each stage. Let's see, Shmuel, good, thank you. Shmuel mentions Visual Studio does a psychrometric complexity analysis too, so that's helpful to know. Thank you, Shmuel. Tim, thanks. Another pointer from Tim. Requirements catalog PDF, www.exemplar, example with an R at the end, .com/testing-com/writings/catalog.pdf. So exemplar.com/testing-com/writings/catalog.pdf. Andrew Cowpack says LDRA testbed claims to have data flow coverage. I haven't used it myself, but it might be interesting. Okay, thank you for that, Andrew. It's interesting to have heard that. I'll make a note to take a look at that at some point. Yeah, it's hard to say much about them if you haven't used them, and I haven't used that tool myself. So it is interesting to know that there is at least something out there that is apparently able to do that, and I think that's really the only way, as a practical matter, to do that data flow analysis. I really don't think that you'd be able to do it by hand. I mean, I guess theoretically you could, but this is just it's tedious beyond belief and very error prone. I mean, the times that I've done it to try to create examples, for example, for this presentation, I made a lot of mistakes that I had to scrub out. So I think that it's not very helpful when you're not really able to apply the test technique itself without making a bunch of mistakes at it. And it's certainly not something that is any fun, and like you'd want to get good at doing it through a lot of practice. Andrew also provided the link for that. It's www.ldra.com/dynamicanalysis.asp. So take a look at that if you're interested in data flow. Oh, here's an interesting question from Tim. We had trouble with testing Firefox where we have runtime generated JavaScript code. Any tips on handling coverage of runtime generated code? Wow, that is a fascinating problem. I have not had to do that myself. Every time I've used code coverage for my own projects or with a client, I've been working with code that was not a moving target, basically. It wasn't generated at runtime. It was code that had been written and was sitting there in files. So I'm not familiar with any of the tools being able to do that. I would assume that's something you'd want to, if that's something that you need to do, then you could check for the tools. Now, another alternative would be if you can control the way that the runtime generator generates code. In other words, you control the thing that's producing the JavaScript. Perhaps you could add a switch to it that would build in the probes necessary to do the coverage analysis yourself, because at least for statement and branch coverage, the probe is a pretty simple thing. All it needs to do is every time it enters a function and leaves a function, it makes an entry in a table that says, I got here, and here is defined as some sort of sequential stamp or something that uniquely identifies where that probe is. And then every time you get to a branch, you put a probe on both the true and the false side of the branch, and also same with the looping and with the switch case constructs. Anytime that the control can flow in different ways, you put a probe in there, and the probe just basically makes an entry in a table somewhere and says, I got here, where here is, as I said, defined uniquely with some sort of unique, perhaps a sequential identifier or something like that. I haven't tried it, but I would think that would be something that would work. And again, it would at least allow you to be able to determine statement and branch coverage. You start getting into condition coverage and multi-condition coverage and that sort of stuff. I think that's going to get more complicated. But this is the old 80-20 rule, that something very simple can get you 80% of your benefit, and maybe that's enough. Let's see. A question from Tom here. He says, you haven't talked much about the psychological side here, how real development teams react to code coverage metrics. It doesn't take much research to show, and people have done it, that code coverage targets will often lead test teams to do whatever they can do to reach the targets, and then any coverage metric will sit there right above the target, not the best for full coverage or for the best code. What can you say about that from your experience? Tom, that is a great point, and this is really, metrics in general, right? Anytime you adopt a metric, you start measuring something, people change their behavior to try to achieve something that they would consider goodness with that metric. You can try to deal with that by making sure that there are not individual rewards or punishments tied to those metrics, but that's again, the very fact that people know that you're measuring something, it will modify their behavior. It's important that you not just have one set of metrics, right? I mean, basically what we've got here with code coverage is a tactical metric that allows us to measure at the unit level the extent to which the unit tests have covered the code that has been written, right? And that at the system level, if you're looking at black box tests, it allows us to measure the extent to which the black box tests exercise the code and identify gaps in that. If it's used appropriately, I think, in a mix of metrics that measure other process, project, and product priorities, then you're less likely to get some sort of fetishization of the code coverage metrics or undesirable behavior distortion of the code coverage metrics. But I concede your point that, like any metric, if you have that metric and that metric alone, you're going to get some really weird behavior out of it. So I think it is important, if you're going to think about introducing this metric, starting to use it, that you do consider those aspects, Tom. I have not seen a whole lot of distortion with behavior with the clients that I've worked with on use of code coverage, but that was because we already had other metrics in place that told us a lot of interesting things, and so this was, we were able to keep the code coverage metric in context, but I can see how it could get out of hand, right? I mean, there was a discussion about code coverage metrics and the software test and performance online, I think, about good versus bad of code coverage and what code coverage told you, and there were some comments about whether code coverage was a good surrogate metric for confidence, and how much confidence should we have in the system. And I would say no. It's really not a good metric to look at to measure the confidence in the system, because, as I said, the unit tests top out at about 50% defect removal effectiveness. So even if you're doing spectacularly good unit testing and you're getting great code coverage with your unit testing, and if that's all you're doing, then 50% of the bugs could easily be slipping past you. So it's a fairly poor metric for how much confidence should I have in the system, unless it's used as part of a number of other metrics. I hope I answered your question there, Tom. It's a huge question, and one that could be an entire presentation on its own. Just this whole how metrics make people do bad things sometimes. But I was more interested in the talking about how the tools or how the metrics are used in this presentation, and what they couldn't do, rather than all of the different ways they could go awry. Okay, question from Tim here. Another question from Tim. Good one. Collecting coverage from manual testing or some automated testing, there need to be multiple test runs, and that's certainly true. We've had some problems trying to combine coverage data from separate test runs. Any tips on this? Interesting. The tools that I have used have been able to do that, have been able to merge the results from multiple runs. So there's a single database where the probe entries are being stored, and they are able to keep track of what's happening incrementally. Though I would suspect that if the code were to change, then that would create a problem, because then the tool might not be able to cross-reference what was new versus what was old, and thus it wouldn't necessarily be able to figure out how to transfer over the coverage results from one run to the next. Some of the commercial tools might help with this, but I think that's a pretty complicated problem. Of now you've got some sort of version control, or at least smart comparison going on in the code coverage tool when it's instrumenting to say, hey, well, have I seen this before or not? Yeah, so I would imagine that when you start talking about multiple runs against changing code, that then you get into some challenges with that. Not real sure how you'd do it other than some sort of manual process at that point. A comment from Tom here. Thanks, Rex. Good points you made answering my question. Thank you, Tom. I'm glad I was able to answer that. It's as a guy who spends a lot of time doing management consulting as well as technical kinds of issues, that is one of the more fascinating things is metrics and the distortion of behavior. Lee Copeland. Hey, Lee, how you doing? Good to see you here. Regarding coverage, high percentages don't necessarily give me confidence. However, low numbers frighten me. That is an excellent point, Lee. Thank you for making it. Yes. While high percentage code coverage percentages do not necessarily tell you that you've found a lot of bugs, or even that you found most of the bugs, if you haven't touched the code, you most certainly haven't found the bugs in it. So, this is back to the principle of testing that says that the testing can show the presence of defects and not prove their absence. So we should be careful in assuming that just because we've covered code that we found the bugs in it, but at the same time we can definitely assume, as Lee's comment points out, that if you haven't tested the code, you certainly have not found the bugs in it. And so that is the one way that coverage measurements can be good at helping you not have false confidence, which is certainly of a great deal of value. There's a question from Shmuel. He says, thanks for the great presentation. Thank you for enjoying it, Shmuel. I'm glad you were able to make it. Says, curious question, what is the statue on the cover slide and how is it related to the material? The statue on the cover side is a photograph that I took in Prague of it's a legendary figure in Prague. It's called the Prague Golem. And basically it's a story from the 1700s or 1600s there was a rabbi in Prague who had a large congregation, I guess you could say, a large group of Jewish people that he was serving, and he was very busy, and he couldn't keep on top of all of their needs, and so he created this thing out of clay and breathed life into it somehow or another, and he had it do stuff for him, useful stuff, but at one point the golem got confused and basically ran amok and started breaking things and hurting people. And so the rabbi had to destroy it. And the relationship there with the presentation is, for one thing, this kind of gets to Tom's point about, could these run amok on us? Could these metrics run amok on us? Yes, they could. But it also was kind of a reference to it's too hard to do this all by yourself. You're going to need a tool, but beware of the tool, because the tool could run amok on you in a few ways. Let's see. Got a question from John Hagar. Good to see you, John. I hope you're doing well. Is it worth the effort to mix coverage of the code during black box testing? Well, yeah, I like to do that. I think that it is worth periodically, if you can run through all of your tests. For example, you've got automated tests, to produce an instrumented version of your code and then run your black box tests against it and check to see what level of coverage you're achieving, because this will tend to be a pretty low number, to be honest with you. And then at that point you can use your knowledge of the gaps of your code coverage to enhance your tests. And I think that is a worthwhile exercise. Let's see, one last comment here. I want to share one from Lee, which is a good comment. He said, I worked on a project once where we found very low coverage at the unit test level. When we informed the developers and their managers, they dealt with the problem like this. They quit giving us the code so we could measure the coverage. Yeah, I think that's, this is one of the examples of distortion of behavior in an undesirable way in response to a metric. And that, that could certainly happen of, if I don't see it, it isn't there. If I don't see it, it's not a problem. So there is a political element to getting this stuff accepted, and you do need to address that for sure. Well, that was a great Q&A session. I really appreciate everybody's participation. We